In the previous lecture, we have solved a problem on shaft carrying gears. So, in this lecture, we are going to solve a problem on shaft carrying both gear and pulley. A machine shaft supported on bearings having their centers 750 mm apart. Transmitted 185 kilowatt at 600 rpm. So the power is 185 kilowatt and the speed is 600 rpm. A gear of 200 mm. So actually in the problem the drawing is not given. Okay. A gear of 200 mm and a 20-degree tooth profile is located 250 mm to the right of the left-handed bearing. Okay. So this gear B is located at a distance of 250 mm to the right of the left-handed bearing. Okay, so this is the left-handed bearing and it is located 250 mm to the right of the left-handed bearing. And a 450 mm diameter pulley is mounted at 200 mm to the right of the right-handed bearing. Okay, so it is to the right of the right-handed bearing. The right-handed bearing is C and it is located at a distance of 200 mm to the right. Okay, so this shaft is not a simply supported one, it's a overhanging shaft. So remember that. Okay, the gear is driven by a pinion. So the gear is driven, which means the gear is a driven gear. Okay, well, it's not a driving gear. It's driven by a pinion with the downward tangential force. Okay, the word is important. The tangential force is acting in the downward direction. So actually in the previous problem no conditions were given, so we have considered the rotation direction and from the direction we have solved the forces. But here the tangential force is acting in the downward direction, so we have to go in a reverse manner. So from the direction of force we have to take the direction of rotation of the gears. Okay, so I'll tell you later. While the pulley drives a horizontal belt. Okay, so the pulley is a horizontal belt drive having 180-degree angle of contact. The pulley weighs 1000 newtons. So the weight of the pulley is given. For example, if the pulley is D, then WD is given as 1000 newton. And the tension ratio is 3. We know that for solving the pulley problem, we have to calculate the ratio between the tight side and slack side tension, and it is given in the problem. It is T1 by T2 is equal to 3. Find the diameter of the shaft if the allowable shear stress of the material is 63 megapascal. So the tau allowable is given as 63 megapascal. Okay, so we'll go into the problem. The first step is calculation of forces. So first we will consider the gear B. Okay, so we know that P is equal to 2 pi n mt divided by 60. The power is given in the problem and the power is same for both the gear and pulley. So you can substitute the value of power and speed and you can calculate the MTB. So that is 2944.4 into 10 power 3 Newton mm. So further the tangential force can be calculated by MT divided by D by 2. MT we have calculated, you can substitute that. T is the diameter of the gear and it is given in the problem, it is 200 mm. So it is 200 divided by 2, you will get Ft is equal to 29,444 Newton. Then for radial force, it is tangential force into tan phi and the pressure angle is given in the problem, it is 20 degree. You can substitute that and you can calculate the value of Fr. So now we have calculated the Ft and Fr for the gears. Now we can draw the force diagram. Okay, so remember that in the problem it is given that the tangential force is acting in the downward direction. Okay, so if the tangential force is acting in the vertical direction, then the gear will be on the horizontal direction. Okay, because we know that if the gear is like this, then the tangential force will act in the horizontal direction. Okay, so if the gears are located in vertical manner, then the tangential force will act on the vertical direction. If the gears are located in horizontal manner, then the tangential force will act on the vertical direction. Okay, so first I'm going to draw the tangential. So you can consider any one of the side. You can fix the pinion on the right side or you can fix in the left side, but remember that the gear fitted in the shaft is a driven one, the power is transmitted from the pinion to the gear. So that is very important. So if it is a driven one, you can directly draw the force. So you don't need to take the reaction forces. So what I am going to do is I am going to draw the tangential force Ft that is acting in the downward direction. So remember that I have not considered any direction of rotation. Okay. So Ft is acting in the downward direction. And since it's a driven gear, then Fr will definitely act towards the left side. Okay. So this is your Fr. So if Ft is vertical downwards and Fr is towards left side, then definitely F will be like this. So this is the direction of F. Okay. So if this is the direction of F, then you can say that this driving gear is rotating in counterclockwise direction. That is why the force is applied in this direction. So if it is rotating in counterclockwise direction, then the gear will rotate in the clockwise direction. So it's very simple. First you have to draw the downward tangential force, and we know that the radial force will always act towards the axis. So after drawing the Ft and Fr, then you can easily draw the F value. Okay. So if you are not clear about the direction of rotation, you just neglect it. You don't need to draw the direction of rotation. But if the F is acting like this, then you can easily say that the driving gear is rotating in counterclockwise direction. That is why it is exerting a force F in this direction. Okay. So okay, fine. So now we'll go to the load diagram. First, the vertical loading. Okay. So here the load drawing has supports on A and C. Okay, fine. The gear is located in B. The Ft is acting in the downward direction. So it is downward. Then in the horizontal loading, the Fr is acting towards left. So Fr is acting towards left side. Okay. So this is all about the forces acting on gear. Then the next one is forces acting on pulley. So first we have considered B. Now we have to consider the D. So the torque is same. So you can substitute the value of torque. MTB is equal to 2944.4 into 10 power 3. And we know that for calculating the tension, we have two equations. One is MTD is equal to T1 minus T2 into the radius of the pulley. And the second one is the tension ratio. That is T1 by T2 is equal to 3. Further T1 is equal to 3 T2. So you can substitute the value of MT in the equation. And in the problem, the diameter is given. It is given as 450 mm. So RD is equal to 225 mm. So you can substitute the values. Further T1 is equal to 3 T2. So you can substitute it. So these calculations we have already solved in the pulley problems. So we already know that you can calculate the T2 value. Okay. So after calculating the T2 value, you can substitute it in the tension ratio equation and you can calculate the T1 value. Okay. So we have calculated T2 and T1 value. Now the horizontal load. So in the problem, it is clearly mentioned that the belt drive is a horizontal one. So the tension will be acting on the horizontal direction. So the horizontal load is T1 plus T2 and it is equal to 26,172.4 Newton. Okay, fine. And the vertical load. So in the problem, the weight of the pulley is actually given. And we know that the weight will be always act in the vertical direction downwards. Okay. So in the vertical load, you just consider WD, that is 1000 Newton. So remember that the drive is a horizontal one. That is why the horizontal load is T1 plus T2. And if there is no self weight, then the vertical load will be 0. But actually in the problem, the weight of the pulley is given. So the vertical load is equal to WD, that is 1000 Newton. Now we can draw the force diagram. So the horizontal load is 26,172.4 Newton. So here actually the direction is not given, whether the belt is acting towards horizontal right or horizontal left, it is not given. So you can consider any one of the direction. So I am going to assume that the horizontal force is acting towards left. Okay. And the vertical load will always act in the downward direction. So the 1000 Newton is acting on the downward direction. Okay. So now we have drawn the vertical loading and horizontal loading. We can go to the second step, that is calculation of bending moment. Okay. So first consider the vertical loading drawing alone. So the total upward force is equal to the total downward force. So RAV plus RCV is equal to 29,444 plus 1000 Newton. Then the moment about the left extreme point is equal to 0. Okay. So 1, 2, 3 forces are acting. We'll start from 29,000. It is acting on the counterclockwise direction. So it is minus 29,444 into the perpendicular distance is 250 mm. Then minus 1000 because it is acting on the counterclockwise direction, minus 1000 into 950. So from A to C it is 750 and from C to D it is 200. So 750 plus 200 is equal to 900. Then RCV is acting in the counterclockwise direction. So RCV into 750. So if you solve this equation, you will get RCV value and you can substitute this RCV value in the first equation and you can calculate the RAV value. And while calculating the bending moment, we know that the bending moment at A and D is equal to 0. So the bending moment at both extreme points is equal to 0. So we can calculate the bending moment at B. So consider the forces acting on the right side. 1 and 2 forces are acting. RCV is acting in the counterclockwise direction and the perpendicular distance is, the overall distance is 750. So it is 750 minus 250, it is 500. Then the 1000 Newton is acting on the clockwise. So it is 1000 into the overall distance is 950. 950 minus 250 from B to D it is 700. So if you solve this, then you will get 4840.7 into 10 power 3 Newton mm. So this is for the bending moment at B. So similarly for bending moment at C, it is minus 1000 into 200. So you will get a negative bending moment value, that is minus 200 into 10 power 3 Newton mm. Now you can draw the bending moment drawing. So from A it is going in the positive direction, then at C it is in negative, then in D it is 0. Then the horizontal bending moment. So use the same procedure and calculate the reaction forces. So this is actually H, okay, RAH and RCH. So you can calculate the horizontal reaction forces. After calculating the horizontal reaction, you can calculate the bending moment at B and C. Okay. So at B the bending moment is positive and at C the bending moment is negative. So you can draw the bending moment diagram. So after calculating the horizontal and vertical bending moment, we can calculate the equivalent bending moment value. So the equivalent bending moment at B is the vertical bending moment square plus the horizontal bending moment square. Similarly, the equivalent bending moment at C is the vertical bending moment square plus the horizontal bending moment square. So this is our bending moment drawing. So from the equivalent bending moment, we have to take the maximum bending moment, that is MB value. So after calculating the MB value, we can go to the next step, that is calculation of torque. So in the first step, we have calculated the torque value. We can take that. So that is 2944.4 into 10 power 3. And MB we have calculated in the previous step. Okay. So the shaft is subjected to both bending and twisting moment. We can use this equation. And in this equation, the tau allowable is given in the problem as 63 megapascal. The KB, KT values are not given, so we can substitute the values as 1. And by solving this equation, finally we will get D is equal to 78.6 mm. Okay. So by using the R20 series in page number 7.20, we can calculate the standard diameter, that is D is equal to 80 mm. The procedure is almost same. The only thing is you have to draw the force diagram very carefully. So since the tangential load is acting in the downward direction, first draw the tangential load Ft, then draw the Fr value. Since it's a driven gear, the forces will directly act. Okay. So this is how you have to solve the problem. So the tutorial problem, a shaft supported on bearings having their centers 1250 mm apart, carrying a pulley of 1250 mm diameter at a distance of 250 mm to the right of the left hand bearing. So the shaft is supported at a distance of 1250 mm and it carries a pulley at a distance of 250 mm to the right of the left-handed bearing. Okay. Then, and a gear of 750 mm pitch diameter at a distance of 350 mm to the right of the right hand bearing. So at a distance of 350 mm to the right of the right handed bearing, it carries a gear. Okay, fine. The shaft transmits 20 kilowatt, the power is 20 kilowatt at a distance of 150, at a speed of 150 rpm. The gear receives power from a pinion with the tangential force. So the gear is a driven gear since it receives the power, and here also the tangential force is acting in the vertical downward direction. So the problem is almost same. The pulley delivers the power through a belt to another pulley of equal diameter horizontally. So the pulley is a horizontal belt drive. Okay. The ratio of tensions is equal to 2.5. So T1 by T2 is equal to 2.5. The gear and the pulley weight. So actually in the previous problem, the weight of the pulley is alone given. So here the weight of the gear is also given. So in the vertical direction, you have to consider the weight of the gear also. Okay, so in the vertical direction, consider this 900 mm. So if there is some another vertical loading is there, then you have to add this 900 mm with that. Then the pulley weight of the pulley is 2700 Newton, it is given. The permissible shear stress is given as 63 megapascal. Assuming the weight of the shaft to be negligible in comparison with the other loads, determine its diameter. Okay. So it carries a gear at point D and a pulley at point B. So in this problem, the weight of the gear and pulley both is given. So WB and WD is given. Remember that we have to consider the weight in the vertical loading. And the gear is a driven gear and it receives the power in the, it has a tangential force acting in the downward direction. Okay, so you can calculate the forces acting on gear, then pulley, then you can draw the vertical bending moment, horizontal bending moment, then equivalent bending moment. Finally, you can calculate the diameter. So after calculating the diameter from R20 series, you can standardize the diameter value.